Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. We've got another great topic for you today. Here it is. Get started with Cscape 10 and Canvas. Well, my apologies in advance here. I'm fighting a bug and my voice is a little rough, but we'll do our best to fight right through. Okay, this is the second part in a two-part series for those of you who are just starting out with Horner. Now, last week, we covered how to get started with Cscape 10 and our entry-level all-in-one controller, the Micro OCS. This week, we have a similar program for you, but we're going to feature Cscape 10 and the more advanced Canvas all-in-one controller. So if you're just getting started with Horner, this is a great place to start. Okay, let's save that voice and get right to it and break down today's topic. Okay. This week's program, from an agenda standpoint, should look pretty similar to last week. We're going to give you a quick introduction to Canvas, our latest and most advanced all-in-one controller. We're going to quickly show you setting up Cscape 10, making a connection between your computer and Canvas, configuring the Canvas hardware, doing logic programming. This week, we're going to highlight IEC. Last week, we highlighted Advanced Ladder. We're going to go through some screen configuration, and there'll be plenty of demonstrations throughout. Now, because some of the material is pretty similar to last week, for those parts that are redundant, I'm going to gloss over them fairly quickly this week. But the beauty of YouTube is you can, freeze frame, back up. You can even go watch some of last week's program as well, which Emily Tedder, our video guru, has already gone through and bookmarked for you. So anyway, whatever you need to do to follow today's topic, all the tools are there. All right, let's get started. Okay, so let's quickly compare Canvas and the Micro OCS. So the Micro OCS is our entry-level all-in-one controller. It's great for simple applications, which includes a lot of stuff. With Canvas, you just get more advanced capabilities. You get more memory, the ability to support larger programs, the ability to have faster scan rates. You have more graphics tools available to you. You have more protocols built in. Micro OCS has the most popular protocols built in. Canvas has those plus a lot more, including IIOT protocols like MQTT Sparkplug, and also the ability to remotely monitor and control your Canvas unit without any additional licensing requirements. So that's really kind of the quick comparison between our entry-level Micro OCS and our most advanced Canvas. When you take a look at the Canvas product line, you have today 5 different models, okay, and available in 4 different screen sizes: 3.5 inch, 4.3 inch, 7 inch, and we've got 2 different 7-inch models, and a 10.1 inch. And all these units have really advanced graphics capabilities, which we'll detail in a few minutes, and you have the capability of having hundreds of objects on each screen and potentially thousands of screens, although most applications have obviously far less than that. Now, of course, like every Horner all-in-one controller, every Canvas model features a full built-in PLC with lots of memory and the ability to support large programs. You can select Advanced Ladder Logic, which we highlighted last week, or you can select the full IEC 61131 program language suite. And today we're going to highlight IEC. Now, for the top 2 units in the picture there, the Canvas 7D and the Canvas 10D, they include some extra connectivity. So they include an extra field bus port in the form of CAN, also an extra Ethernet port, and that's 2 completely separate Ethernet ports. And all Canvas models are programmed using Cscape 10, which is our all-in-one software package. Let's talk about the I/O options for Canvas. Now, all Canvas units come with some built-in I/O options, okay? And they're detailed there on the right. You can see that ranges from no built-in I/O at all the way up to about 40 I/O points. And most models support, well, really, all models except for the one with no built-in I/O. All models feature not only digital I/O, but also analog I/O, as well as some really nice advanced high-speed counting capability. Now, if you want to have your I/O distributed on the machine, or maybe fully located in the backplate, you can also add what we call OCS I/O, which is our expansion I/O system. And in that scenario, when you add OCS I/O, you could potentially add hundreds and hundreds of I/O points for a really large I/O system because Canvas has the horsepower to support that. Okay, another thing that separates Canvas from our other product lines is the advanced graphics. So I've just got some quick screenshots there on the screen of some of the examples of the advanced graphics. So newer objects, kind of better drawn objects, if you will, more advanced capabilities, certainly more advanced trending, more advanced alarming, more advanced recipes. Those particular features were redesigned from the ground up to take advantage of Canvas's advanced graphics engine, and all those capabilities are there. So we're not going to dive too much into those today. We're just going to get you started with drawing some screens, but we've got lots of videos available on our YouTube channel that goes into detail on the Canvas video capabilities. Now, when it comes to communications, whether that be industrial protocols or IIoT protocols, which stands, of course, for the Industrial Internet of Things, Canvas is just jam-packed with protocol capability. And every protocol you see on the screen there and every protocol that Canvas supports is all built in at the factory. So there is no field licensing or one-time upgrades or anything like that that's required, as it is on some of our other products for some of the protocols. For all these protocols that are supported with Canvas, you have all these protocols available to you. And there is some variability between how many serial ports, for instance, or how many CAN ports or Ethernet ports are available on each model, but that's detailed on the screen there. I'm not going to dive into that in too much detail today. But again, lots of communications capabilities with Canvas. Okay, so let's get out of the slides and dive right into the demonstrations. Okay, I'm going to quickly gloss over the setting up Cscape part because I covered it in a little more detail last week. But the first step, after you've downloaded the install from our website, and you do have to create an account on our website if you haven't done that already, then you download the software, you run the install program, and then you should finish with it asking for you to log in. So at this point, you would use the same login credentials that you established on our website. Okay, and if you want to skip this step, the login step, the next time you fire up Cscape, then you hit the Keep Me Logged In button. Okay, now we are logged in. The one thing that you need to take a look at from a setup standpoint, and we're going to go to the Cscape circle here and settings, is whatever style of logic that you prefer to use, make sure it's checked here. Okay, now if you're just new to Horner and you're not sure what you're going to use, I would suggest for new programs that you either support advanced ladder that's variable based or IEC, and I would check them both so you have the ability to select which one you prefer every time you open a new project. And I would also recommend that you don't select enhanced IEC default because that's only supported by Canvas, and what I would do is just select that manually whenever you fire up a new project that's using Canvas. Now, if you use Canvas all the time and you use IEC all the time, you might choose to go ahead and check that. All right, so that's really the one thing you need to take a look at from a setup standpoint. Now, in terms of setting up your desktop the way you want it, I covered that last week. I'm not going to recover that this week. You can quickly jump to that bookmark if you need to. All right, let's go ahead and create a new file. Okay, and this is where we have the choice based on that setting that we just reviewed. So for this week, I'm going to go ahead and use IEC 61131. Last week, I showed an example of getting started using advanced ladder. So if that's what you're preferring, again, you can go back and reference last week's video because that portion of the video, creating the logic, etc., is going to be the same for Canvas. It's only when you get into the creating the screens and some of the other details with Canvas that you see some variation. So this week, we're going to highlight IEC 61131. Okay, so we've opened a new program. All right, now the next thing we need to do is establish a connection with the controller. Okay, and as you can see, we don't have a connection yet. So let's quickly review a slide with some information on it, and then we'll come back. Now, when it comes to the physical connection between your computer and Canvas, like the Micro OCS, you have a couple different options. But with Canvas, we really recommend that you utilize Ethernet as your connectivity from your computer to Canvas. Why are we recommending that? Well, that's because we can more quickly download larger files over Ethernet, so the downloads don't take as long if you perform those over Ethernet versus performing them over USB. So that's the recommended connectivity for Canvas, at least the most recommended. Now, if you'd prefer to program using USB, that's also an option. Okay, so that's also available to you. And most Canvas models still feature USB Mini B, which is shown there in the lower left-hand graphic, if you will. That's Mini B. And we have a cable available from Horner that you could use between your computer and that type of connection. And then the Canvas 10D model, because it's the newest, it features USB-C. So in that scenario, of course, you'd use that form of connectivity. And then we also have a couple different programming cables available for connecting to USB-C on a Canvas 10D, and those are shown there on the screen. Now let's go through all the programming details with you. All right, now let's establish that connection between our computer and Canvas. Again, verifying in the lower right-hand corner here, we do not have communications. And because this is Canvas, we're going to use Ethernet to communicate with it. Now, we could use USB. It's not quite as fast. If you want to learn more about connecting with USB, check out last week's video. I'm sure Emily has that part bookmarked, but we're going to use Ethernet today. The first step is to make sure the Ethernet address of the Canvas unit is compatible with our local LAN. So let's head to the bench and make sure that is set up the way we want. All right, now in your case, you'll probably have the default program that's loaded in the unit from the factory if you just open it up. I happen to have a program in my unit that I used for demonstrating USB cameras with Canvas. So if you're interested in that topic, check that out on our YouTube channel. Okay, so I need to pull up the system menu to access the Ethernet settings. And I do that by touching the upper right-hand corner. Got to hit the right spot there. Okay, so as you can see, the system button has appeared. Okay, and if you're familiar with the menu system in the traditional Horner controllers, you'll notice that it's quite different with Canvas. Okay, let's select Network. Okay, and LAN. All right, and we have a couple different things we could do here. Now, this is a Canvas 10D. It has 2 LAN ports, and we're connected to LAN 1. So one thing we could do is we could turn on DHCP and let our local network kind of assign the address for us. But I'm not going to do that today. I'm going to type in a fixed address for IP address 1, since LAN 1 is what we're connected to. So let me select that. Okay, and then I'll type in the new address. So I want 192.168.0.253. That's what I'm interested in there. Okay, so you can see I've successfully changed that. Everything else is perfectly fine in terms of the net mask and the gateway. All right, very good. All right, now let's go ahead and escape out of the menu system here with the back and the close. All right, and let's head back to Cscape. Okay, now what we want to do is we want to go to the connection wizard. All right, and again, we want to connect over Ethernet. Okay, so we make sure that one's selected. And we want to make sure that this IP address matches what we've just configured Canvas for. So it does. I'm going to hit finish. All right. And now once I've done that, we're going to wait a couple minutes. And actually, I forgot to plug in the LAN 1 connection, my LAN cable. So let's do that now. All right. And now that I've plugged in the LAN cable, we wait a few seconds and there we go. All right, so we locally are connected to address 253. That is the default CAN address on the unit. All OCS units shipped from the factory have a default CAN address of 253. So our local address is 253. Our target, the one we actually want to talk to, is also 253. And idle or stop mode is the mode in which the controller is in. Okay, so once we are sure we've actually plugged in our Ethernet cable to the right LAN port, then we go through the connection wizard, set the IP address, and we're good to go. All right, one last thing I want to do before we dive into programming, and that is this. Let's go ahead and go to hardware config. All right, and you'll notice that this particular controller doesn't match. Why is that? Well, that's because when we first fired up Cscape, we did not have a connection with the OCS controller. So Cscape 10 picked the default controller, which happens to be an XL4, okay, which is one of our more popular models. Well, I don't have an XL4, obviously. I have Canvas. So let's press auto config, all right, so that the correct controller shows up. Once we're physically connected and talking, we can use that auto config button. And then the last thing I want to do for this step is I want to go to the LAN1 config, and I want to hard code. In my case, this is what I want to do. I want to hard code the proper IP address so that when I do a download, okay, it assigns the proper IP address to it, okay? Because if I didn't change this to match what it's supposed to be, when I did a download, it would change it to that improper address and I would lose communication. So I'm gonna go ahead and configure all of these here, and I'll go ahead and type in the DNS server here. You know, you can use the same address as your gateway maybe if that's how your system is set up. I'm gonna go ahead and use the standard Google DNS here, one of them at least, 8.8.8.8. Okay, so the key port though here is the IP address and the net mask. Those are the keys. Make sure you have those configured properly. Okay, and okay. And again, going back here, local target, not in run mode, looks like we're good to go there. And if we take a look at additional details here, we can see that the model is equal. Okay, the model we're talking to is equal, but the program is not equal. So we don't really have a program that we've got here yet established. So therefore the program isn't equal even though the model is. All right, let's move on to the next step. And the next step is to finish the hardware configuration. So we're gonna go back to hardware configuration, which we can get to from a variety of different ways. I'll just go ahead and select this here. Okay, if you remember, a couple minutes ago, I went in and set the LAN address to its proper setting. Next, what I would typically do is I would go into local IO and configure the local IO. Now, my particular Canvas unit is one that doesn't have any built-in IO, okay? But if it did have built-in IO, well, let me go ahead and do this. Let's temporarily change to a model that does have built-in IO. Let's say a model 6, all right? And let me demonstrate how you would configure that. And then I'll come back in and get rid of that configuration because it doesn't match what I have on the bench. Okay, so if I had a model 6 on the IO side, that has 6 analog in and 4 analog out. So we can go to local IO, config, module setup, and then we have the 4 different types of IO that we can configure. Digital inputs, digital outputs, analog inputs, analog outputs. And we could go through and configure those. And let me do that quickly now, okay? On the digital input side, okay, is it positive logic or negative logic? Almost always it's positive logic, and it applies to all the inputs. And again, this is for the Model 6. If you have a slightly different model of IO, you'll have slightly different choices, okay? High-speed counter IO mapping, where all the high-speed counter IO is mapped. It has a default here. We'll just leave that alone. Let's say for now we don't have any high-speed counting, but if we did, this would be the mapping we would use, and this is where we would set between 2 counter mode and 4 counter mode, and we'd also have the ability to set up some filtering on the high-speed counter side, as well as set up what we want the counters to do, to totalize, to frequency count, to measure pulse widths for quadrature, etc., etc. Okay, but we aren't doing high-speed counting today. All right, so that's the input setup. If you don't have any high-speed counting going on, it's just a matter of selecting between positive logic and negative logic. On the digital output side, this particular unit has 12 outputs. The first 2 could be used for some higher speed options, like a PWM signal, where you vary the duty cycle, you know, or the frequency of an output pulse train. It could also be used for firing a output or having that output fire based on an encoder position, for instance. Okay, but most of the time, if again you don't have any high-speed outputs, then it's just going to be configured for normal. You can also come down here and make the outputs either hold their state or be on when they're in stop mode or when the controller's in stop mode. That's pretty rare. Most of the time, you're going to leave that alone as well. Okay, on the analog input side, this is something you're probably going to need to configure. So by default on the Model 6, all the analog inputs are disabled. We're going to want to set those to whatever we have here. Let's say that we have a PT100 RTD on the first 4 channels. So let's go ahead and select that. All right. And then let's say that we have, let's say, just a 4 to 20 milliamp input on the next 2 channels. All right, and then this is our filtering. That can be a value between 0 and 7 to give us, a balance between quick response and a stable signal. So 0 to 7 is the range. I like to usually start with a 3 here. All right, and I'm going to leave it in degrees C as my units. All right, and I'll hit OK. And then on the analog output side, something similar. You've got 4 analog outputs to deal with. Let's say they're just all, let's say the first 2 are 4 to 20. And the second 2 are 0 to 10. All right, now what do we want to have happen to the analog outputs when we go into stop mode? By default, they're going to hold their value. Let's say we want them just to go to 0 instead, or go to a value of 0, which is generally going to be 0 or 4 milliamps or 0 volts, depending on the format. Okay, so that's my hardware configuration. All right, so I've now configured my Canvas unit with built-in I/O. Now, this step I'm going to go back and undo because I don't have a Canvas unit with a Model 6 I/O. I have a Canvas unit with no built-in I/O. So I'm going to change this back to Model 0. Of course, that's a step you wouldn't take if you had built-in I/O you just configured. And I'll say OK. All right, so now I'm back to having an equal model, which I should, and my program isn't equal because I haven't done any programming yet. And the next step is to start programming. Okay, now we previously created this new project for IEC. Now let's go ahead and start adding some IEC logic. All right, I'm gonna go over here to the project navigator, okay? Before I dive into this, let me just do a quick tour here. This is the project navigator where we can one of the ways we can navigate to all the different elements of the program. This is our program variable list divided between global variables, and there are some pre-established at the factory, retained variables, there aren't any here. And then those are really the only 2 groups that are established by default of variables. All right. And then over here we have our project toolbox, which will populate with different programming functions depending on what we happen to be programming. Is it logic or is it a screen, etc. All right, so let's head back over to the project navigator. Under control, let's expand that. And then under logic modules, let's expand that. And then we have main loop modules, subroutine modules, and UDFB modules that we can start adding here. We're going to start with a main loop module. I'm going to highlight that and right click. And under new logic block, I'm going to select the specific language that I want to program this block in. Let's go ahead and select a ladder logic block for this demonstration. All right, I'm just going to do a simple ladder logic configuration. Okay, so once I've added that, I can rename it. Okay, let me go ahead and give this a name. We're going to do some simple motor control here. So let's call it motor control. All right, you'll notice I have a tab on my desktop and this logic routine here. Now, if you've used Horner Advanced Ladder before, you can see this doesn't look the same in terms of this particular ladder editor that's tied to IEC. This one is its own unique animal, if you will, but it's really very easy to use. If you'd like to have kind of some tips and tricks beyond what I show you today, we did a great video a couple weeks ago with John Seymour, who's one of our senior application engineers from one of our distribution partners. And we had some great tips and tricks that you might want to check out after this. Okay, but let's just get started very simply. All right, to create a new rung, we highlight in the upper left-hand corner. We press this first button here, which inserts a contact. When it does that, it automatically creates a new rung, rung number 1. All right, let's do some simple motor control. I'm going to double click here, and type in a variable name. Now I'm doing the variable naming on the fly so far. Now I'm going to call this start push button. Now this push button, if it's physically wired to an input, I need to map it. So let's say it's wired to the first digital input, which is %I1. And I could either just type in I1 or %I1. I'm going to type in %I1. Okay, we have our start push button. Let's say our motor is what we have here as our coil. I'm going to double click here and I'll type this as motor run. Okay, maybe that's our motor starter. And again, if it's connected to a physical real world output, I need to map it here. It is, let's say it's the first output. So that would be %Q1. Digital outputs are Q in the Horner mapping scheme. Okay, now I'm of course going to need a stop button in here. Where do I need that? Well, I need it between these two. So if I highlight here, I would press this button here, which inserts a contact after. All right, and let's say this is our stop push button. Now again, I'm creating these variables on the fly, and you don't have to. I could predefine these. Let's say again a real world input. Let's say %I5 is what this one is physically wired to. Okay, and then the last thing we would need for this dirt simple start-stop circuit is a seal around the start push button. So I'm going to highlight here and press this button here, which says insert a parallel contact. Okay, well, see, I screwed up there. That's not what I wanted to do. I didn't want to press my button here. I wanted to press it here. So let's go ahead and leave highlight to the left. I'll hit the delete key on my keyboard and that deletes that. Now I will highlight this contact and press insert parallel contact. There we go. That's what we wanted. All right. So if I double click here, then I'm going to make this the motor run contact. Now I could just type in motor and it will auto populate, or I could just browse my tags here until I find motor run and double click on it. Okay, so this is a dirt simple start stop circuit right there. Let's go ahead and add a timer. Just so you can see how timers work, we'll go ahead and time how long the motor run contact is running. Okay, so to do that, I'm going to create a new rung. All right, so I can, highlight here, for instance, press the insert contact button. It adds rung 2. All right, let's make this, let's say we want to time motor run. Okay, so we'll do that. And we want to insert our timer in between here. So we want to find the insert function block after button, which we'll do here, and it inserts a generic function block here. Now I could double click in here and select my timer counter in there. Okay. The other thing I could do is I could go over here to the toolbox and scroll down under timers and counters and find the on timer that I want. Okay, so if I want an on timer with 100 millisecond resolution, I can select that and then click and drag it over the top of the one I previously created. There we go, and now we have our timer that we've inserted. Now, I'm going to expand this. That's one of the nice things you can do with IEC. I'm going to expand it so I can read this better. I'll double click here. I need to name this timer. Okay, so I'm going to call this the motor run timer. I could call it whatever I want. Okay, I don't need to map it to anything. It's just an internal timer. So I just say yes. Okay, and then I need to assign a preset value. Now this could be a variable or a constant. I'm going to make it a constant 5 seconds. So that would be a count of 50. So with 50 tenths of a second, that's 5 seconds. And then this is my accumulator, which I need to assign here. I'm going to call this motor run time. Okay, I'll call that. Okay, and again, this is just a variable. That's an integer, internal, don't need to map it to anything. We're good to go there. All right, and then if we want to, if we're going to actually use this coil when this timer expires, we could go ahead and do that. I'll go ahead and give this a name. I'll call this motor run 5 seconds. Now, if we were only going to be, Boolean is right, okay, everything's fine there. If we were only going to be using the timer and we didn't really care about the coil, we don't have to assign anything to the coil. It can just sit there. All right. Now, one thing that might be handy for those of you who like things to be nice and neat, once you've done a few rungs here, there's a button down here called Align Coils. So press that, and now the coils are aligned. So that'll help those of us that have a need for everything to be lined up nice and neat. Okay, so that was a simple ladder routine that we added here. But one of the benefits of IEC is that we can also do structured text in other languages. So let's go ahead and add a structured text routine as well. Okay, so I'm going to go back here under main loop modules, right click and click on or select new logic block. This time let's select structured text. Okay, and let's say that this structured text block, we're just going to use it for some analog math. Okay, let's say that's what we're going to use it for. So I've given it a name, analog math, and we now have a new tab that has shown up called analog math with just an open workspace here that we can start typing in structured text. So let me go ahead and do a comment here. This routine is used for analog math. Okay, that's always good to have comments. I didn't put any in the ladder routine. I'll show you how to do that here in a minute. And let's just go ahead and do some simple math here. Now, I'm going to go ahead and create ahead of time my variables. All right, so I'm going to go down here under global variables. I could also create retain variables. Global variables are always reset at 0 on power up. Retain variables retain their value on power up. So I'm going to go under global variables, and you'll see there are some that have already been established at the factory and the ones that I added already on the fly. They've been added to this list. Okay, so I'm going to right click within global variables and hit add variable. And I'm going to start creating variables. Okay, so let's create one for our analog input coming in. Let's just call, and maybe let's say it's a temperature. Okay, temp raw AI. All right. And then next, let's add one, let's say that is a real value of that. Okay, so temp raw AI, let's make the next one temp raw real. Okay, now one important step that I didn't do when I created this one, you need to set the type. So the raw AI coming in from the analog input is an integer value, okay? And then we're going to convert that to a real value with this variable, okay? And then let's say we have a couple more variables. Let's add another variable that is a temp degree C, okay? So we're going to convert our raw value to degree C, and that's going to be a real, let's say, okay? And then let's add another one that is temp deg F. Okay, and again, these are just examples. And again, let's not forget to add the type there. That's important. Now, if we had multiple analog inputs and we were going to be doing the similar processing on all of them, we could make these variables that we've created into arrays by adding a dimension here. So let's say we had 4 analog inputs and we wanted to have a one-dimensional array with up to 4 elements in it. Then in this column here, I would type a 4. Okay. And then I would have raw AI sub 0 through raw AI sub 3. But I'm going to go ahead and delete that. I don't really need that. Oh, I don't want to delete the entire variable. I just want to type in and have a single dimension on my variable here. Oh, it doesn't like that. Let's just delete that. There we go. So I highlighted that particular entry and deleted it instead of deleting the entire variable. Okay, so I've created my variables ahead of time, which is sometimes easier to do with structured text. All right. Now let's go ahead and do a little bit of programming to do this simple math that we're going to do. All right, what I like to do, because I don't use structured text all the time and I don't have all of the syntax memorized, is I like to find my instruction that I want to use and drag it over into the workspace. So I'm going to find conversion operations, and I want to convert my raw value coming in to a real value. So I need a convert to real function. So I'm going to drag that in here. Okay, and it went ahead and did that. All right, so that's good. So that's our any to real function. I'm going to add a space in here because I have to type in front of it. If I kind of hover over that, it will eventually show me if I do it properly. Let's see here. Oh, let me take that space out and do it again. It will eventually show me the syntax. Come on, show me the syntax. All right, trust me, it's supposed to show me the syntax. And as you probably saw, I did briefly flash there. There we go. It's just a little pickier than I would like it to be. There we go. I need to be more patient. Okay, so basically our input is the variable we want to convert, and our output is the real variable. Pretty simple stuff. Okay, so let's go back here and follow this proper format. Okay, so the variable that I am converting to is temp raw real. So I should be able to drag this here. There we go. Temp raw real equals, okay, that's our assignment statement, any to real, and then in parentheses, what is the value that I want to convert? Well, that value I want to convert, which I can either drag or just start typing, is temp raw AI. And then we can't forget our semicolon at the end. Okay, so we've converted our raw AI over to a real value. Now we need to convert to degree C. Let's do that next. The way we're going to do that, and I'm just going to drag this here, temp degree C equals this value here, okay, which I'm going to type in. I could drag it, but I'm going to type it in, times 20 in this case. And that's because with most Horner built-in analog inputs that are high resolution that have temperature support like RTDs and thermocouples, they're usually in 20th degree C increments is the kind of value or the format that those are in. So I've created a variable for degree C by just multiplying by 20. And if I want to create a degrees F variable, again, I'm choosing to drag here. I could just type it in. Okay, and this one is just our standard formula for conversion, and that's going to be temp deg C times 1.8 plus 32. And we don't need to have any parentheses here because we're going to do the multiplication first, which is what we want, and then we're going to add 32. And we can't forget our semicolon. All right, so we've created a simple little routine here. Let's double check and make sure we haven't got any syntax errors. All right, and I'm going to do that by pressing the error check button. Okay, so, oh, that looks bad. No, it's not bad. Basically, it says non-fatal compilation errors are found. Do you want to continue? I will say no. These non-fatal errors are, we haven't created a screen yet, okay? It's just a warning that says we haven't got any screens. The screens are all empty. No big deal. We haven't started in that part yet. So let's just go ahead and close that down. All right, so we've successfully created a motor routine in ladder logic here. We've successfully created a structured text routine here. Now, one last thing, it's kind of out of order, but let me show you how to add a comment here. So I'm going to highlight where I want the comment to go, and then I'm going to hit this insert comment line button, double click here, and then just add the comment. So I'm just going to add a simple comment. You know, this is the start stop logic for the motor. Okay, something really simple there. And I'll hit the little check mark, and I've inserted a comment. Comments are always good. And one other thing I'll show you for our structured text, and I could have just clicked over here as well, is one of the beauties of structured text is you can just add comments here, convert integer coming into a real variable. Okay, so that's nice about being able to put those comments wherever you want them, line by line, if you want to comment every single line. All right, so that's a quick look at adding logic. Now, a step I could have taken earlier would be to go ahead and save our program. I'm going to do that now. So to do that, by default, our program just gets an untitled name. They're all Untitled 1, Untitled 2, Untitled 3, etc., etc. Let's go ahead and give it an actual name. So I'm going to go back here to the Cscape circle, hit save, and I could have done save as well. But when you hit save, when you have an untitled program, it prompts you to go ahead and give it a real name. So I'm going to call this motor. Oh, let's go ahead and make sure our keyboard is connected properly. Okay, motor control demo. Let's just call it that, and I'll put IEC on here so I know this IEC, and I'll hit save. All right, and now we have a name to our program. Next, let's start building a screen. Okay, let's take advantage of that. So to do that, I'm going to go back to the project navigator. Under user interface, I'm going to expand that. I'm going to go to main screen, right click, and say new screen. Okay. It creates a new screen by default, screen 1. I'm going to give it a different name. Let's go ahead and call, let's just call this motor control. Okay. All right. Okay, now what happened here is it added a screen editing area here, a new tab with the name of the screen and the number of the screen, followed by a screen editing area. Now it's zoomed in a little bit further than I'd like. We've got a 10-inch model we're looking at here, so I'm going to back it up a bit. Okay, let's go here. Okay, I'm going to back it up a bit. And by default, we have this, happens to be a 10.1-inch screen area with a grid system on here. Now, let's do a couple things. First of all, I'm going to right-click, and I'm going to go to Grid Setting. I'm going to get rid of the primary grid. That's the big blocks. And I'm just going to snap to the smaller grid, which is the dots. So now I have kind of clean things up the way I want to from a grid standpoint. So I can still line things up, but it's not as blocky as I'd prefer it to be. Okay, and the next thing I'm going to do, one of the things you can do in Canvas is you can set up a background. If you have a specific background in mind, you can set up a background for your screen. So I'm going to right-click and hit Set Background. And you know, it can be just a color, which is fine, but it can also be something a little more than just that. So let's go take a look at the available patterns, and let's select a pattern. Now I'm going to go ahead and select a pattern, but I want that pattern once I select it, because remember, the pattern isn't necessarily sized for a specific screen. I'm going to have it maintain the aspect ratio of the pattern, and then just clip it as needed. Okay. All right. So I'll hit Select Pattern now, here and here. All right, and then we get a menu of all the kind of standard patterns that are available. So again, this is just something to kind of snazz things up a bit. Let's just select, you know, some sort of, let's do this brushed aluminum look here. Okay, now if I want to add a tint to that, a different color to it, maybe tint it blue or tint it green or whatever, I could do that as well. But for now, I'm just going to leave it in its default form. Hit OK and OK. And then as soon as I click on the screen, it goes from just being dropped there to taking up the entire screen. Okay, so this is what that brushed aluminum pattern's, you know, going to look like here on my screen. All right, let's say that we want to just go ahead and quickly show a push button and a pilot light for the motor. Okay, so let's go ahead and do that. I'm going to go ahead and under Live Graphic Data, I'm going to expand that. And I'm going to select a lamp or indicator, okay, because I want an LED or a pilot light that shows when the motor is running. So I'm going to click on that, and then I'm going to click and drag to size, okay, a pilot light. Now the default is this light bulb. Obviously, well, not obviously, but I certainly am not looking for a light bulb there. So what I'm going to do is I'm going to select a different indicator, okay? So let's just go ahead and do something fairly straightforward. Let's select this particular indicator. All right. And then let's next give it a legend plate. Okay. So under legend plate properties, I'm going to go ahead and give it a border if I want to. Hit legend, and then I'll just type this in. So I'm just going to hit run here. Okay. Is the motor running or not? I could, you know, obviously name this whatever I want. All right, I should probably make it a little bigger now that I think of it. That's probably a pretty small size. Okay, let's make it 30. Okay, and okay. Let's get the colors the way we want. Let's say on is bright green, but let's make off a dark green, and we can go ahead and leave the gradient on there. We don't have to use a gradient, but I'll go ahead and leave that there. And then we ultimately need to tie this to a variable. So what's the variable we want to tie that to? Well, we want to tie it to motor run. Let's find that variable, or we could have typed it in, and we hit OK. All right, so there's our run LED that's going to indicate when the motor is running or not. All right, now let's say we also want to display how long the motor's been running, that motor timer value. Okay, so let's do that. So to do that, there's a couple ways I can do it. But I'm going to go to Live Text Data, and I'm going to pick a numeric data field. Okay, and then I'm going to click and size it the way I want. All right, and then double click on it to configure. And this time I'm going to start by assigning a variable to it. I don't have to do it that way. I'm just going to start by assigning a variable to it. All right, so let's find our motor run time, which is the variable that we want. Now, this is a 16-bit variable. We really should have selected that first, but it was already selected. If we had a 32-bit real variable, we would have selected 32 bits there first. We don't want assigned decimal. We just want decimal because this count of the timer is going to just be numeric. We're only counting up to 5 seconds, which is a count of 50. So we don't need to show, all the different digits. Now, if we want to show this in tenths of a second, we can do that. So we can show here, we can do xx.x or 12.1 to imply a decimal point. So when the value is 30, it's 3.0 is the way it'll be shown on the screen, even though the value is still 3. I'm going to add engineering units here of an S for seconds. I'll make the font bigger. Let's go ahead and make it good sized here, 40, a bigger size. This is not a writable data field. We'll uncheck that. And let's go down here to legend and change this to runtime. All right, and we'll make that font a little bit bigger. All right, and let's change the, let's look at the display styles. I'm okay with a rounded rectangle. Let's go ahead and leave that there. But on the background, let's get a little fancy here and select a different background. Let's go ahead and do another pattern, okay? And select a pattern here. And this time, let's select our brushed aluminum. Let's see, is that what I want? Or do I want to do something a little different? Let's select something a little different. Let's not do everything exactly the same. All right, let's do kind of this blue background here. Again, I'm just fancying things up a little bit. All right, okay, and okay. And I think everything looks pretty good the way I want it. I'll hit okay again. And there we go. So we now have runtime and run. All right, now if we want to start the motor from the touchscreen, not just display it, we'd want to add a push button or some sort of button, all right, to do that. So let me do that here. Let me go ahead and collapse that. And under touch objects, let's select button/switch. I selected that, click and drag to size it. All right, I'll double click. And let's select our switch type first, okay? Under push buttons, I'm gonna go ahead and select this guy, okay? I'll change the colors the way I want them, okay? Actually, let's just, we don't have the ability to change those colors. We'll just use it as is, and then go back up here, select our variable, which we want to be our start push button, okay? Start push button, there we go. And let's see, what else do we want? We have a 2-position momentary button. I think what we're going to want to do is leave it like that. Okay, now with this particular button, you don't have a built-in legend plate. Okay, so you'll need to add one of those. So I'm gonna size this a little bit. Okay, and then I'm gonna add a legend plate in the form of just a separate text object. Okay, so I'm gonna go under fixed objects and text label, and click and drag to the size, approximately. And I'm gonna call this motor start. And I'm going to give it a good size here and hit okay. There we go. And so now we have a motor start button. Okay, and we have a run LED and we have runtime. So just really simple stuff here. All right, now let's say for an example, well, okay, here's something we better do. We don't actually, this button, okay, I assigned it to start push button. Now that was a mistake. Why was that a mistake? Well, the start push button, when we previously created that, was wired to a fixed input. So it's actually a physical button. So if I'm gonna start from the touch screen, I need a parallel button here. So I need to create a new variable, not use this existing one. So I'm gonna create a new variable and I'm gonna call it start touch button, or TB for touch button, all right? And this does not exist yet. So when I type in a new variable, it asks me if I want to create it. I say yes, and because it's not wired to anything, there's no reason to map it. I just say yes, and now I have a new variable called start TB that if I use it in my logic, I can use to start the motor. So we better go back to our motor control routine and add in a parallel contact to motor run. Okay, so I'm gonna click on here and I'm gonna click the because that's the area where I want to add the parallel contact. And I'm going to click on the Insert Contact Parallel. It adds that, it adds it there to the logic. And I want this now to be my motor TB. Okay, so I'm going to go ahead and type that in there. Hit Enter. Okay. Oh, see, it's creating a new variable. That's something else. If I remembered the variable wrong, then it's going to create a new variable. Oh, I didn't want to do that. I wanted to select one I'd already created. I'm going to hit Cancel here so that doesn't get created. Double click on here and then pick it from the list. And I'm going to pick it from the list, and there it is. Start TB is the one I actually want. Okay, very good. All right, so there we go. Start TB is what we want. All right, so I've added a parallel contact, which if we take a look at our screen, we'll see that that's the button that's going to make that turn on. Now, if I want to create a stop button, let's do that so that we can stop it as well. But instead of creating these separately, let's highlight these two objects. Okay, right click and hit copy, right click and hit paste, and now let's move those down here. All right, and let's make this a stop button. So I double clicked on the text. Okay, and then I need to go in here and create a variable, and I'm going to call that variable stop TB. Okay, that's what I'm going to call it. It does not exist. That's fine. Don't need to map it to anything, so we're good there. Okay, and now I've added that to my screen, but now I need to add that to my motor control routine. So what am I going to do here? Oh, here's a mistake that I didn't show before. So when I added this stop push button, it's shown as normally open. We don't want that, do we? We want our stop push buttons to be normally closed. How do I take a normally open push button and make it normally closed? Well, I highlight it and I press the space bar, and it will, the next choice for contacts is normally closed. So that was a mistake I almost made here. All right, now let's move over, or well, let's just leave that highlighted here. I want to add an additional stop button, but with start buttons, you add them in parallel. With stop buttons, you add them in series. So I highlight my current contact and I say, add another contact, let's say to the right. Let's make it normally closed by hitting the space bar, and then double click on it and select from our list stop touch button. And now we've added an additional stop button. All right, so we've fixed this by making these normally closed and having two of them in series. We've added our additional push button to start it in parallel, and we are good to go. All right, now one other thing. Let me go ahead and show you how we could display our temperature value in degrees C. So let's go back to our motor control screen, and let's add a data field here that's going to show this temperature in degrees F, let's say, for our temperature coming in. All right, so again, back to our screen. Let's add a data field, which is going to be live text data. It's going to be a numeric data field. Let's click and spread it out. Okay, all right, double click on it. Now the variable that we want to tie this to is a real variable, and real variables are 32 bits. So the first thing we have to do is change 16 bits to 32 bits. All right, this is a real variable coming in, so let's make it real. All right, and then let's tie a variable to it. And the variable we want is temp degrees F. So this is only showing 32-bit variables, okay, because that's how we've specified it. All right, so temp degrees F, 32-bit. It's not writable. This is just a readable value. And then how do we want to display it? Okay, now this is the floating point value, so we can display it with however many decimal points that we want. For any kind of real value, though, you're going to, really probably for a temperature, anything more than 1 decimal point probably doesn't make any sense. So I'm going to go ahead and just show it with, if my biggest temperature is going to be, a few hundred degrees, then I can make it, 123.1 with 1 decimal place. I can make this an F for degrees F. I can make this font larger, okay, and then for my legend, I can just call this temperature. Okay, temperature, and let's bump this up a little bit. Okay, and because we can, let's go ahead and go to display style. We'll leave it as a round rectangle, and then under background, let's go ahead and do another pattern. Again, you don't have to do this. I am just demonstrating how you can do this. And just for consistency's sake, let's go ahead and just select that same blue background again. Okay, okay, and okay. There we go. All right, so we've created another data field for displaying this temperature from our routine, our structured text routine. All right. Okay, so we've created a screen. We've created some logic. Now it's time to do a download. To do that, first, this is a step I don't want you to screw up. First, I'm going to double check and make sure under hardware config that my LAN 1, since I'm programming over Ethernet, matches what I want, and it does. Okay, just a step to be safe. We don't want that IP address changing mid-download. All right, now that I've verified that, let's go ahead and start our download. So what I'm going to do here, we've got communications. I'm going to hit the download button. Okay, it's telling me that register allocation between downloads and variables can change. That's okay. We'll hit all right. Okay, it went and did a quick error check, and everything's fine. All right, now we're going to do a smart load, and it's going to compare what has changed with what needs to be downloaded. Now, everything has changed in this program, basically, from compared to the one that's loaded in it now. So it's going to take a little while because it's going to download everything on this pass. The logic program, the hardware configuration, the graphics, all that is going to be downloaded on this first download. On future downloads, not as much will change, and therefore less will need to be downloaded, and it won't take quite as long. Okay, so let's let this finish. All right, now that it's finished, there's one last step we need to take, and that is to make sure that we're in run mode. Now, in my case, I started out not in run mode, so I'm going to need to manually put it in run mode. In your case, your unit may have been in run, and then you downloaded it, and then it went back into run. Okay, so the behavior is, if it's in run to start with, it goes into stop mode, downloads the program, and puts the controller back into run mode. If it starts in stop mode or idle mode, it ends in idle mode. So I have to manually start it. Okay, now there is an online programming mode with Canvas that I'm not going to show you today, where you can do downloads without having to stop your program. So that is available. It's called online change. So that's something to be aware of. Okay, I'm going to go ahead and put the controller into run mode here. I'll hit this icon here to go into run mode. And now we are in run. Let's take a look at it on the bench. All right, as we can see, our program has been downloaded. Let's test it out. Let me go ahead and press the start button. Okay, the run light turns on. Our run timer times up. Should go to 5 seconds and stop. You know, the motor doesn't stop automatically. Let's go ahead and stop that manually using the stop button. Okay, our temperature is shown at 32F. That's because I don't have any values coming in from I/O. So those values are 0. So that's why that value is showing at 32F. If I had some real world data coming in on analog input 1, obviously that value would be changing as well. All right, so everything looks like it's working well on the bench. Now let's take a look at debugging. Now to go into debug mode, there's a couple ways I can do that, but I can go up here and press the debug button. All right, now this takes a few seconds. Effectively, Cscape 10 is going out and reading all the values of all the variables in the program. And now if I switch to one of my logic routines, all right, I can see the status of every variable. Okay, so my runtime is 0, my motor's not running. I am passing power flow, or would pass power flow through the stop buttons if my start button and my seal were on. Let's go ahead and start the motor. Okay, so I pressed and released the start button. You can see that reflect. Now my runtime, I can't see that here. We can fix that just by making this a little bit wider. There we go. Now everything fits on the screen. So now we can see our runtime as well. And if I stop the motor by pressing the stop button on the screen, then we're good to go there. Now, interestingly, while in debug mode, if I look at my structured text routine, I can see all the variable values here as well. Now, of course, the reason I'm getting zeros coming in is because I don't have any I/O actually connected to that Canvas unit. I've got a Canvas unit with no built-in I/O. All right, but it is very handy to be able to see all the values for all your variables in structured text, not just the ones that you hover over. Okay, so that does it for our content for today. This is the point in our program where I remind you we're here every Tuesday, or just about every Tuesday at 2 o'clock Eastern. And if you watch live, you can ask questions in the chat section and we'll get those answered real time. We've always got somebody standing by. If you watch on replay, which a lot of you do, we have such a large library of videos. Just give us any comments or questions you may have in the comment section and we'll get those answered just as soon as we can. We've posted our training schedule for 2025, so get on our website and get your spot reserved. We have both basic and advanced courses available in 2025. Okay, lots of ways to interact with Horner. Check out our website at www.hornerautomation.com. Find that video you're looking for from our YouTube channel. We've got hundreds to choose from, and interact with us on LinkedIn. Next week, we've got a really informative show for you. We're going to show you how to use Festo Motion with the Horner OCS. We're going to use some advanced tools like user-defined function blocks. We're going to show you how to connect it to a Canvas OCS. You could use other models, but we're going to show you how to do it using Canvas, and we think it's really going to be informative. So for those of you who have motion control applications and you'd like to utilize your Horner OCS, we're going to show you the way to do that easily and efficiently. Okay, if you haven't subscribed to our channel yet, don't hesitate to do so. It doesn't cost anything. And if you choose notifications when you subscribe, you'll be notified every time we go live or every time we post a new video. Okay, so until next week, when we talk Festo Motion and the Horner OCS, let's all get out there and do some good.